Okay guys, this is guess method part 2 on assignments 32 and 33. This is the guess method remediation and kinematics word problem practice. I'm going to take the work we did on the first YouTube video, the half of the guess method, GU and half of E, and I'm going to take these equations and work them out. I'm going to show you two ways, which will take me a little bit of time, which means I'm only going to do a couple of these, alright? So keep the video kind of short. Alright, so you remember we picked this equation because it's the equation that has A in it, V final, VI, or V initial, and change in time, right? You have to use an equation that uses everything here for right now. Later on it might be different, but for right now this is what we're gonna do that, okay? All right. So I'm gonna do this the scholastic way, in which I solve for V final, because it says V final equals, right? So that's why I circled it. I'm looking for that. So I have to get rid of this divide by t. The opposite of divide by t is multiply by my change in time, right? Whenever I do to one side, I have to do to the other, so I'm going to multiply by change in t over here too, and I rewrite my equation. Change in t equals v final minus v initial. It's a minus v initial, okay? Now, is v final by itself? No, I have to do the opposite of this. So instead of minus, I'm going to plus the initial. Okay? Whenever I do to one side, I have to also add over here. I'm going to show that when I rewrite my line. A times change in t plus the initial equals v final. Nasty. Okay, now, since I've solved for v final, now I want to plug in my numbers. This is the way that you make sure you divide and add everything correctly. I like this. Okay, so A, what was my A? 1.1. Multiply by change in t is 10.5. Add the initial, which is 0, which means I don't even need to put that in the calculator. In fact, if you have a 0, I would not put it in the calculator. So if you have a 0, do not put that in the calculator. Otherwise, your calculator is really smart. It'll do things like PEMDAS. Sometimes it'll mess up, especially when you're dividing. So if you have a 0 in your equation, don't even write it. So do not put 0 in the calculator. Not put the 0 in the calculator. Otherwise, you can get mistakes. Okay? Do not put the 0 in the calculator. All right. So this comes out to 11.55, and we're solving for velocity, right? Which is velocity unit is meters per second or kilometers per hour, right? In this case, we're doing meters per second. Okay, so meters per second, right? Okay. Okay, I'm going to solve it the second way. Move this out the way. So let's say you don't like working with these letters, right? You don't like moving letters around. You don't have to. You pick the equation, same way. Velocity final minus velocity initial divided by change in time. Okay, I'm just copying my equation. Just plug the numbers in from here. Okay, you don't have to move anything. 1.1 is my acceleration. See where I got that from? 1.1 right here, right? And 1.1, you see where I got that from? Here, here. So I'm rewriting. My V final I do not have, so I'm just going to leave it. Okay, so V final minus V initial. There it is, it's 0, right? V initial 0. Do I put this in the calculator? No. Remember zeros? Zeros. Come on. There we go. Do not put 0 in the calculator. Okay? Divided by change in time, which was 10.5 seconds. Okay, cool. I'm done, right? Wrong. I have to still solve for V final. So you see how I'm going to end up doing the same work. Just if you like moving numbers, that's better. Okay, that's fine. So times 10.5 to get it out of the bottom. Let's divide by 10.5 to get it in the opposite. Whatever I do to one side, I do to the other. So I have to multiply this side by 10.5. So I'm going to show that in my next line. 10 point. This is like messing up on me. 10.5 times 1.1 equals, and remember, we're not going to write that in the calculator, right? So V final. Okay, so this is equal to 11.55, and it's velocity, meters per second. You see how I get the same answer? I do the same amount of work, but it's just, if you're comfortable moving around numbers, that's fine, okay? When you work out another one, I'm going to work out a fast car accelerates from 0 to 100. So, okay, we got to pick the equation, right? So what equation uses all three of these? I want you to pause and try it. Okay, pause and try it. Pick the equation that matches all of these letters, all these symbols, and write it down. Pause it and try. Okay, so the equation for this one is the same equation, the first equation. Acceleration equal to velocity final minus velocity initial over my change in time, okay? So let's plug in the numbers. A, I don't know what A is, so I'm going to leave it, equals. The final was 100 minus the initial, 0. I'm not going to write that in the calculator, right? My change in time is 3.2. So I'm going to divide 100 by 3.2 in the calculator, and you get 31.25. And it's acceleration. So what's the unit for acceleration? Kilometers per hour. So it's going to be kilometers per hour squared. Kilometers per hour squared. And the reason it's kilometers per hour squared and not meters per second squared is because look at your givens. Your givens were in kilometers per hour. So this has to be like kilometers per hour squared. They have to match, okay? Okay. Hopefully you didn't try moving anything around, right? Okay. Next problem, I want you to pause it and try it out. Try it out without looking. Okay, see if you can write the equation, plug in the numbers, and find the answer. Okay. Pause it and try. Okay. The equation that has A, D, velocity initial, velocity final, but no time, is going to be equation 2, right? Here we go. Acceleration equals velocity final squared minus velocity initial squared over 2 times my displacement. Okay, I'm going to work this out without moving any letters around, okay? The next one I'll work out by moving letters around, okay? All right, let's see. What's my acceleration? We don't know. It says what is the acceleration? So I'm going to go ahead and acceleration equals, what's my velocity final? Put this stuff back. That's my velocity final, right? Okay. My velocity final was 11.33. Square that, right? 0.33. Getting the same little problem here. 3 squared, okay? Minus my initial velocity. It's from rest, right? So velocity initial 0. Squared, am I going to write this? No, I do not put that in the calculator. Okay, and it's 2. I have to copy the same thing, 2. So 2. Displacement, it's 100. So 2 times 100. Okay. You don't want to put this in the calculator because it's going to end up going 0 divided by 200 and then times whatever this is. Okay, so try that in the calculator. You end up getting 0.64, and this is in meters per second. So this is going to be meters per second squared. Okay, 0.64 meters per second squared. Cool. Okay, let's do the last one on here. Let's do one more. Let me go full screen. All right, you're traveling at 45 meters per second. Hit your brakes to a stop. So pause it and try to see what equation this is. You need something with velocity, acceleration, velocity final, distance, and time. Okay, here's what it is. It's the third equation. Displacement equals velocity initial times time plus 1/2 acceleration times your time squared. Okay. All right. See, I don't have to move anything around because this is asking for how much distance. So the distance is already isolated. So let's go ahead and rewrite this here. Try plugging it in. If you didn't get this right, write this down and try plugging in the numbers. Pause it and try. You're not going to learn if you just copy what I copied. Okay, 45 goes here. My time interval is 3. Now I got a plus 1/2. Remember in the calculator you put 1/2 like this. Or 0.5, right? Either way. My acceleration is, where 15, but it's negative, right, because it's slowing down. My t is 3 squared, right? You got to square it. All right, so this comes out to, what's my calculator? Who has a calculator? I got one. Or not. The calculator's missing. Here it is. All right. All right, so 45 times 3 plus 1/2 negative 15 times 3 squared. Right. Comes out to 67.5. 67.5. You have to be real careful, and I think I told a lot of you today I wasn't very careful. I just realized right now that we said this was a negative acceleration, so you have to make sure that this acceleration here is negative. You put 202.5. I made the same mistake today. That's okay. But this is the right one. We'll get it right on Monday. Yeah. And we'll make sure to go over that. All right. Good job. Any other questions? Make sure to see me for tutoring. Look over this stuff really carefully. Make sure if you copied this, that you go back and try it again without looking. Okay, you have to be able to do this on your own.